Okay, so this is the actual lesson, the content that would be testable. You do need to use the skills from the previous video here in the concepts I'm going to teach you in advanced functions, but the work you're going to see on the test would be much more similar to what we're going to do here. So this is lesson 5, how do you solve a rational equation? So let me just get the pencil again. Not that. Okay. So if it's a polynomial, then you would just factor to find its zeros. If it's a rational expression, then we're going to use the skill set that we reviewed in the previous video. I would have to get a common denominator here. First thing I'm going to have to do, though, is make sure everything is on one side and we are equal to 0. And now I'm going to have to multiply 1 by x plus 2 and 1 by x minus 4. And actually, I put in this extra step just to show you how you get the common denominator. We can see how this is 1 over x minus 4, and this is 1 over x plus 2. Now I would need to add x plus 2 plus, that should say x minus 4, because it was x minus 4. Don't need to factor or expand. Let's say don't need to expand the denominator. This is going to give us x plus x is 2x, and that's going to be minus 2. So that should read 2x minus 2. And then I would not need to find the zeros of this. So I now have a over b, in a sense, is equal to 0. If a over b is equal to 0, then the numerator needs to be 0, so a needs to be 0. So that gives me that 2x minus 2 needs to be 0, and that gives me that x is 1. So the solution to this would be x is 1. And if we wanted to check, we would then plug a 1 in here. 1 over 1 minus 4 plus 1 over 1 plus 2. This gives me negative 1/3. This one gives me plus 1/3. And those do indeed equal 0. So it does check out. So that is the correct answer. So moving forward on to the next slide. All right, so what you're going to do is you're going to apply the technique we did here. So what would we do? If we have more than one rational expression, we'd have to bring them together and get a common denominator. We would then factor the numerator. The zeros of the numerator are our solutions. In this case, you do have to address this. So I'll give you a bit of a hint. You are going to have to bring this over to the other side and set it equal to 0 and then solve from there. Avoid the temptation to do this. X minus 4 equals 2 times 2x plus 1. You can get the correct answer doing it that way, but it turns out what we're going to do next is we're going to put inequalities in there, and when you multiply by this, you're going to have a problem. So I'm going to suggest that you don't do that, because then you'd have to worry about whether or not this was positive or negative. So just that we're applying the exact same skills as we would when we move on to rational expressions, I want you to write this. 2 equals 0. I want you to bring the 2 over and then get a common denominator, because that skill set will transfer readily to inequalities. All right, I'm going to pause so you can do some work. All right, so taking this up now, as I had mentioned previously, avoid the temptation to just do a cross multiplication here. It will work because this is an equation, but it will not work when this becomes an inequality, either greater than or less than, because you're going to then have to worry about, oh my goodness, should I flip the inequality or not? You'll have to consider 2 cases. So I'm going to show you how to do it this way, so that when we get into the next I'm not sure if that's the next lesson or the lesson after, or maybe it's in the next unit, but we are going to have to solve inequalities. So getting a common denominator now. My common denominator is 2x plus 1, so I'm going to need to multiply negative 2 by 2x plus 1. That gives me x minus 4 minus 4x minus 2. That gives me negative 3x. Negative 4 minus 2 gives me negative 6. So this is negative 3x minus 6 over 2x plus 1. Again, I have an expression, a over b, it's a quotient. A quotient of 2 values is supposed to be 0. The numerator needs to be 0. So negative 3x minus 6 needs to be 0. That gives me negative 3x needs to be 6, so x needs to be negative 2. And now I'm going to check to make sure it is correct. So x minus 4 becomes negative 2 minus 4. 2x plus 1 becomes 2 times negative 2 plus 1. That becomes negative 6 over negative 3. Negative 6 divided by negative 3 is indeed 2, so it does check out. The restrictions in this particular example were x not equal to 0, negative 0.5, but we're not actually going to use that in the solutions because we were being asked where these two expressions would be equal to each other. They will be equal to each other when x is negative 2. And now graphically what I'm showing you, in green, that's the graph of x minus 4 over 2x plus 1. The blue is the graph of g at x, or y equals 2. And notice they intersect right here. Where are they intersecting? They're intersecting at negative 2. And that's the solution we found there. So that's the process for solving these. So we'll jump forward now, and I'm going to get you to try another one. Here's the next one I want you to try. And again, the process would be bring this over to this side. We're not going to do any cross multiplying because we want the technique that we're using to apply to inequalities. So bring this over to this side, then get a common denominator. Again, I'm going to pause so that you can do the work, and then we'll walk through the solution. All right, so as I mentioned, I'm not going to do any cross multiplying because I want the technique that I'm using to be able to extend to inequalities. So I'm going to bring this over to this side. There's the minus O. Instead of plus that, it's minus that. My common denominator is now going to be x minus 1 times x plus 1. I will multiply negative 2 by x plus 1. And now I need to multiply negative, in brackets, x minus 8 by x minus 1. That's where that bit is coming from. And now expanding this first part, I get negative 2x minus 2. I'm expanding this, that times that is negative x squared. I'm going to have that times that is plus x. That times that, or that was plus 8x. That times that is plus x. That times that gives me minus 8. And then simplifying, we get negative x squared. Then we're going to add this, this, and this. That'll give us plus 7x. Adding those two, we get negative 10. So after getting our common denominator and simplifying, we have this quadratic negative x squared plus 7x minus 10 over that one. I can factor a negative out of this and get x squared minus 7x plus 10. And this factors readily into x minus 5 times x minus 2. So again, we have a quotient of two expressions. We want to know when that expression is equal to 0. So what we need to do is ensure that the numerator is 0. The numerator will be 0 when x minus 5 is 0, or when x minus 2 is 0. That gives me x is 5, or x is 2. And then I'm going to check. So this one is checking x equals negative 2. That's my first, or x equals positive 2. That's my first check. So there's the negative 2. Plug in a 2. 2 minus 1 equals. Plug in a 2 there, I get 2 minus 8. Plug in the 2 here, I get 2 plus 1. This gives me negative 2 over positive 1, which is negative 2. This gives me negative 6 over positive 3, which is also negative 2. So that checks out. The next check is for 5. So again, plugging a 5 in here, we get negative 2 over 5 minus 1. We now have 5 minus 8, and there we get 5 plus 1. Negative 2 over 5 minus 1 is negative 2 over 4, which is negative 0.5. This becomes negative 3 over positive 6, which is also negative 0.5. So it checks out. The correct solutions would be they're going to intersect at 2 and they're going to intersect at 5. And visually, so you can see graphically. Here is the graph of negative 2 divided by x minus 1. That's the graph in green here. The blue graph is the graph of x minus 8 times x plus 1. And notice they intersect right here. That's x equals 2. And they are intersecting right there, which is x equals 5. So there's graphical representation of what it was you were doing. You were finding the points of intersection of these two graphs. All right, let's try another one. This one's a little bit more complicated because we now have 4 terms here. It might be easier. There'd be fewer negatives if you bring this one to this side. than there would be if you bring all of those to the other side. But it doesn't really matter which way you do it. Cross multiplication I don't even think would be something you'd be able to apply here because we have too many terms. But remember, my suggestion is to avoid that because that will not work when we do inequalities. So again, I'm going to pause so that you can do some solving of that equation. All right, as I mentioned, I felt it would be easier to bring this to this side because then I'd minimize the number of negatives I have to work with. So 2 over x plus 1 over 1 minus x minus 1 over x equals 0. Our common denominator, remember this is over 1, so our common denominator will be x times 1 minus x. And so what will happen now? I'm going to have to multiply 2 by 1 minus x, and I just want to show you quickly that technique that I had talked about before. So the 1 minus x's would go, and I definitely would have 2 over x, so I know I've done that correct. And I undo that. And well, this one is more obvious if we take a look at that one right there. That definitely is 1, so that part is correct. And now let's take a look at this bit. That definitely is 1 over 1 minus x, so that part is correct. And then now let's look at this part right there. And that gives us our minus 1 over x. So we have found the common denominator correctly. Expanding, that becomes 2 minus 2x. That's plus x minus x squared, so plus x minus x squared. The plus x from there, distributing minus 1 plus x. We have minus x squared. We have negative 2x plus x plus x plus x. That's plus x. And then we have 2 minus 1, which is 2. So this is negative x squared plus x plus 1. Again, we have an expression of the form a over b equals 0. So if I have a quotient that is supposed to be 0, then the numerator needs to be 0. So we need to solve negative x squared plus x plus 1 equals 0. That gives me x squared minus x minus 1 is 0. The discriminant is not a perfect square, so I went into the quadratic formula. So we need negative b, which is 1, plus or minus the square root of b squared is 1, minus 4. The product of a and c is negative 1, and this becomes 5. So our solutions are x equals 1 plus root 5 all over 2. And that would be this one right here. And the other one is 1 minus root 5 all over 2. And that would be this solution here, where they're meeting right there. Now, I'm going to kind of walk you through. I just checked one of them, and then you should try and see if you can check the other one. More difficult now because this is an irrational number. So I'm going to replace x with 1 plus root 5 over 2. There are 3 places where I need to do that. That was done there, it was done there, and it was done there. I can, if I were to invert and multiply, this is actually in a numerator. So that's where it's written. Checking my original solution, that negative should not be there because there is no negative there. That's the original equation. So this 2 should be in the numerator. That 2 can be in the numerator, and 2 times 2 gives me 4. There's the 1. What I did over here, we could have a common denominator here. So I wrote that as 2 over 2. And this would give me 2 minus 1 minus root 5 when I distribute. And then the 2 from this denominator comes up to the numerator. So that's how I got to there. All right, now the next step, I just simplified 2 minus 1 there, and I got 1 minus root 5. Now what am I going to do? On this side, I'm going to multiply by 1 minus root 5 over 1 minus root 5. This is 1, so it won't change the value of the expression. I'm just going to undo that just so that you can see that. And now I'm going to need to multiply this by 1 minus root 5. The 1 will have to be multiplied by 1 plus root 5 times 1 minus root 5. The 2 is going to have to be multiplied by 1 plus root 5. There's the common denominator. And on this side, when I saw what the common denominator was going to be over there, that's why I chose to multiply by this. And again, this is 1, so it won't change the value of this expression. So 2 times 1 minus root 5 becomes 2 minus 2 root 5. Expanding here, we get 4 minus 4 root 5, plus 1 times 1 is 1, minus root 5, plus root 5 is 0. Root 5 times negative root 5 is minus 5. So that's where all of that came from. That was expanding that. And this becomes 2 plus 2 root 5. And when you simplify this, you get your 4 plus 1 minus 5 plus 2 gives you 2. Minus 4 root 5 plus 2 root 5 gives you minus 2 root 5. So that solution does indeed check out. You can test the other solution, 1 minus root 5 all over 2, and prove that that one works out. All right, next example is going to be an application question. These application questions will all be done the same way. You'll be told something about a rate. It could be 2 hoses filling a pool. They are each doing it at a separate rate. They don't specifically give you the rate. They tend to tell you how long it would take for it to fill the pool. So if you use this hose, it will take this long to fill the pool. This hose, this long to take the pool. And then we work from there. So I'm going to walk through this example with you. So when Maggie and Emily can deliver flyers to all the classrooms in the school, when they work together, it takes 42 minutes. I'm going to change that to a rate. So working together, they can deliver 1/42 of a flyer per minute. All of these problems will be done the same way. You're going to have to take this and use the reciprocal to figure out flyers per minute. This is all the flyers, which we don't know how many there were, right, are delivered in 42 minutes, but I can guarantee then that 1/42 of a flyer per minute was delivered. Emily is going to work at a rate of 1 over X flyers per minute because she's going to be able to deliver, it's going to take her X minutes to deliver all the flyers. And again, I don't know how many flyers there are. So X is the amount of time it takes for Emily to deliver the flyers, so 1 over X flyers per minute. Now it tells us that Maggie, when she works alone, can finish the job in 13 minutes less than Emily. So if Emily takes X minutes, then Maggie takes X minus 13. So then she is working at a rate of 1 over X minus 13 flyers per minute. Again, this is the number of minutes to deliver all the flyers. Then 1 over that is what fraction of a flyer that could be delivered per minute. So 1/42 of all the flyers per minute, 1 over X of all the flyers per minute, 1 over X minus 13 of all of the flyers per minute. When we add these two together, we should be able to get the same rate as this. And so that's the equation you're now going to be solving. So Maggie's rate, which is this one, plus Emily's rate should be equal to the rate when they work together. And then what you're going to do now is you're going to then just solve this. So I'm just going to pause for a second because I don't want the solution to pop up right away. All right, so I just wanted to revise so that there wouldn't be anything written on this page. All right, you're going to attempt to solve this now. Again, this is the rate. It takes 42 minutes to deliver all the flyers when they work together, so that's 1 over 42 fractions of the flyers per minute. And Maggie can work at this rate per minute. This one's Maggie. This one's Emily. So Emily works at this rate per minute, and Maggie at that rate per minute. When you add those two together, you have to get the total rate. All right, what you're going to do now is solve this. And remember the suggestion was bring everything over to one side, set it equal to 0. We're not going to employ the techniques of cross multiplying because they don't work in inequalities. Okay, I'm going to pause so you can finish that one off. All right, so let's discuss the solution. I'm going to bring this over to the other side. I get minus 1 over 42. My common denominator is now going to be 42 times x minus 13, written right there. I'm now going to have to multiply this 1 by 42 and x minus 13. That's where that's come from. I'm now going to have to multiply this 1 by 42 and the x. That's where that piece came from. I'm now going to have to multiply this negative 1 by x and x minus 13. That's where that piece has come from. And if I expand, I get 42x minus 546. There's the 42x. Expanding here, minus x squared plus 13x. If we group like terms and simplify, you will get negative x squared. 1, 2, 3, adding all the x terms, you get 97x. And our constant, there's only one of them, minus 546. And again, an expression of the form a over b equals 0, means the numerator needs to be 0. So there's the numerator, it needs to be 0. I'm going to multiply by -1 because I do not like my leading coefficient to be negative. That gives me x squared minus 97 plus 546 equals 0. That factors nicely into x minus 91 times x minus 6. And now we're looking at x being 91 or x being 6. I'm now going to check my answers. So when I plug a 6 into here, I get 1 over 6. When I plug in a 6 here, I get 1 over -7. And that's giving me a negative rate. And that makes no sense. Now, what would that mean? That would mean people are delivering flyers to her. So that makes no sense, so we're going to reject it. I'm going to show you that the 91, so x is 91, and again, this is the 6 minutes. So if Maggie delivered in, not Maggie, this one is Emily. If Emily took 6 minutes to deliver, then we're getting a negative rate for Maggie, so we're going to reject it. So that means that this solution must check out. So Emily's going to take 91 minutes to deliver her flyers, which is what the question asked initially. It says, how long will it take for Emily to deliver the flyers? We now know it looks like 91, but I'm just going to verify that it works for you. So 1 over 91, 1 over 91 minus 13. Common denominator is going to be 91. That becomes 78. So 91 times 78. I'm going to get 1 times 78 plus 1 times 91. That gives me 169 over 7,098. And that does indeed reduce to 1 over 42. So the correct answer here is it will take Emily 91 minutes to deliver all the flyers. And when I'm going to suggest that you absolutely look for these questions in the textbook. They'll all be done the same way. You'll be given something about the total amount of time. You'll be told something about a comparison between the two. One takes maybe 10 minutes longer or they're a bit slower. And then what you're going to do is use the reciprocal to get an item per a time unit, right? So our rate is always going to be per time. So I want time over here and a fraction of an item there. These problems are all done the same way. And then there's one more problem that you can look at. I'm not going to go through this one. And it's doubtful that if we were meeting face-to-face that was a long lesson that we would have had time to get there. So this is just extra practice, still done the same way. Bring this over to this side. You're going to have to factor everything out, reduce if anything reduces before you get a common denominator. And then you can check with the solution online because the class notes with full solutions are definitely online. Okay, so this was a fairly long lesson, including the review. Again, thanks for watching, and the next lesson will be 6.